Today we're going to be working with problem solving with linear functions. We're going to have 4 word problems. I'm going to work the first word problem for you guys, and then we're going to finish the other 3 in class tomorrow. So it says linear functions can be applied to many real-world situations to analyze the situation and to make predictions. So let's look at problem number 1. Problem number 1 says the A shift at Citgo must drain an oil vat. 40 seconds after the plug has been released, there are 13 gallons remaining in the vat. After 1 minute, 10 gallons remain in the vat. Assume the number of gallons varies linearly with time. So I know my graph is going to be linear because it tells me in the equation. Now, let's go back and look. It says I got 40 seconds, and I'm going to have 13 gallons. Now, notice what it says next. I want you to underline this. It says 1 minute, I have 10 gallons. Well, my 40 seconds and 1 minute are 2 different numbers, so I need to change my 1 minute into seconds. So how many minutes are in a second? I got 60 seconds. So on some of these problems, you guys are going to notice that you might have to actually do some changing of the numbers. So here, let's look at part A. It says we're going to identify what is represented by the independent and dependent variables. Remember, my independent is X or Y. It should be my Y value. I should have that my independent was time in seconds, because remember I had to change the 1 minute to seconds, and my dependent will be the gallons remaining in the tank. So based on that information, part B says I'm going to fill in the table at the right. So what will be my 2 coordinate points? You should have 40, 13, and 60, 10. Now make sure that you had changed that to 60 and you don't put the number 1 or you're going to miss the rest of the problem. Part C says I'm going to place the data in the scatter plot. I'm going to label the axis. So on the right-hand side, I want you to label the graph and actually plot the points. And in a minute, I'm going to scroll down. You'll be able to see what the graph is supposed to look like. So part D said, is this graph going to be continuous or discrete? Now remember, when I give you specific points to plot, that it's discrete. Continuous means that that graph is going to go on forever and ever and ever. Well, the point of following the instructions tells me that I'm going to have a linear equation. So what's always my answer when I have an equation? You should have said continuous. So part D should be continuous. Now let's look at E. E wants to know whether the function is increasing or decreasing. So if you look at how my graph is titled, I have time in seconds on my x-axis, and I have gallons remaining on my y-axis. And you know what? I made a mistake before. Your independent variable is your x variable. I think I said y. So go back and change that. Okay, so once you graph the equation, your line should look like this. So my graph is decreasing because it is going down. Remember, the vat is losing oil. Okay, so F says explain what parameter changes to the linear parent function y equals x must occur to fit a trend line to do this. Okay, what it wants you to do is to describe if I had y equals x, which is this graph right here. What would happen, what would I have to change in order to get the graph that I have based on this information? So for part F, I should notice that my equation has been flipped. So what's another word for flipped? You should say reflection. If I have a reflection, what happens to the signs? I should have a change sign. So here's what I want you to copy for F. And let me explain it. We just talked about the reflection. So when I reflect, that means my M is now negative. I also am going to have to shift my graph vertically so that my y-intercept is higher. Here my y-intercept is larger than 1. So I'm going to add to the b value. Remember, y equals mx plus b. B is my y-intercept. It also tells me that I need a less steeper slope. So I'm going to have a vertical compression by a factor less than 1. Now, what they have here is after making the changes, the trend line was y equals negative 0.15x plus 19. They get that equation by plugging it in to stat edit. So when you have a calculator, you're going to plug in 40 and 60 into L1 and 13 and 10 into L2, and you're going to run the regression line. So let's go to G. It asks me what equation results from using a linear regression on the data with the calculator. Remember, plugging this into the calculator, that's what we just said. We're going to get y equals negative 0.15x plus 19. So now let's look at H and I. H says I want you to find the y-intercept and what does it represent in the real world. Well, based on the information for G, what number is my y-intercept? You should have said 19. So the coordinate point is 0, 19. So what is that going to represent in the real world? You should have said that the tank is going to start with 19 gallons. That's how much I started with. At 0 seconds, when I have not unplugged anything, I started with 19 gallons. So now let's look at I. I says find the x-intercept, and what does it represent in the real world? So here, in order to find the x-intercept, you are going to plug in a 0 for x, or excuse me, you're going to plug in a 0 for y, and you're going to solve. So what you should have answered is your x-intercept is approximately 126.7, 0. And here, that means that in 120 seconds, my tank will actually be empty. Okay, let's look at the last question. It says explain the slope in terms of its units, and what does the slope represent in the real world? So here, my slope, based on the equation, is negative 0.15. And it's going to represent the rate at which the tank is emptying. Remember, another word for slope is rate of change. So I want you to answer all of these questions. We're going to work questions 2, 3, and 4 in class tomorrow, and you will turn it in. If you want to go ahead and attempt these questions, question number 2 is identical to number 1. You should be able to get that done.